All right, here we are for lesson 2-1A. Today we're going to be looking at graphs and intervals on graphs. But before we do that, we're going to do a warm-up here. Give the domain of each function. This first function is a rational function, so it does not matter what's going on in the numerator. All I care about is what's going on in the denominator. I need to make sure that x plus 3 is never equal to 0. If you subtract 3 on both sides, you get x equals -3. That's the number that I am not allowed to plug into this function, because if I do so, the denominator ends up to be 0. So my domain here would be x in the set of reals where x is not equal to -3. That's a no-no right there. Number 2, or letter B I should say, h of x equals x squared minus 13. Well, what is this? This is simply a parabola. Okay, now you may know where the vertex is, you may not, but if you look at any parabola, the domain of any parabola is all real numbers. X in the set of reals, easiest way to do it. Square root function, f of x equals the square root of x plus 7 minus 8. Don't care about the minus 8. All I care about is what's going on inside this root. What do I need to make happen? I need to make sure that x plus 7 is always greater than or equal to 0. If you subtract 7 on both sides, x is greater than or equal to -7. That's my domain right there. Don't even need to do anything else with it. Okay? So today we're going to be talking about functions where a function is positive and where a function is negative. So the graph to the right is the function f of x equals x squared minus 4. It's just a basic parabola. It has x-intercepts at -2, 0, you can see, and 2, 0. All right? The zeros of a function that crosses the x-axis separate the x intervals where a function is positive or negative. What do we mean by that? When we talk about a function being positive or negative, we're talking about the y values of the function. So if you look at this graph, where this graph is positive is where the y values are positive, and that happens in quadrant 1 and in quadrant 2. All right, so the quadrants get labeled just like this. Quadrant 1, 2, 3, and 4, they go in a counterclockwise direction. And so functions are positive in quadrants 1 and 2. All right, so all the y values above the x-axis. So we would say that f of x is greater than or equal, is greater than 0 in the intervals where the graph is above the x-axis. Above the x-axis, and we'll talk about what do we mean by that word intervals. Okay, functions are negative in the lower two quadrants, so that's quadrants 3 and quadrant 4. So we would say that f of x is less than 0 in any intervals where the graph is below the x-axis. All right, so let's take a look at this guy right here. All right, so one way to look at this function, f of x equals x squared minus 4, or you could factor it out. You could say that this is x plus 2, x minus 2. All right, so sometimes it's easier to look at it like that, x minus 2. And so this function has two different factors, both with a degree 1, and so the graph crosses the x-axis at each solution. All right, so my graph is crossing the x-axis at each solution at +2 and -2. So we would say that f of x is greater than or equal to 0. So now you'll notice we're including equal to 0 here. All right, so if you just think about where f of x is greater than 0, that's everything up in quadrant 1 and 2. But now we're including 0. Okay, so where is f of x equal to 0? Well, it's equal to 0 at 2 and -2, and it's greater than 0 above those two. All right, so the way we would say this is that f of x is greater than or equal to 0 all the time from -infinity all the way up to -2. Why do we say -infinity? Because this graph keeps going up as it moves to the left. So to the left of -2, this graph is always above the x-axis, and to the right of +2, it's always above the x-axis. So f of x is greater than or equal to 0 on the intervals for x in the intervals from -∞ all the way up to -2, and because we said equal to 0, we can include -2, and then it goes below, so now it's negative underneath, and then it comes back to 2, and it stays above the x-axis all the way to infinity. So we have those two intervals where my graph is greater than or equal to 0. Where is f of x less than 0? Again, when we say where is the graph less than 0 or where is the graph negative, that's everything below the x-axis. So this graph is below the x-axis from -2 to +2, but because it doesn't say equal, we don't include 2 or -2. All right? Hopefully your screen is not getting darker on the video here because I'm not sure what's going on with my computer. All right. Let me see. The graph below is the function f of x equals x minus 4 squared with an x-intercept at 4, 0. Where is f of x greater than 0? Where is f of x less than 0? Where is f of x equal to 0? Why does f of x bounce off the x-axis? All right. So I actually said where is f of x greater than 0 here, and then I have an equal sign under here. So maybe we'll just take that guy off right there. How's that? We'll just take that off. So where is f of x greater than 0? Well, it's pretty much greater than 0 all the time except at +4. All right? Except at +4. So this graph is greater than 0 in the intervals from -∞ up to 4, and you'll notice I'm not including 4 in there, and then again past 4, so we don't include 4, up to +∞. Okay? Now, while we're talking about why we're skipping 4 there is because at 4 we're actually equal to 0. So where does f of x equal 0? Remember this little notation here? So this is saying when y is equal to 0, what's the x value? Well, x equals 4. Okay? Where is f of x less than 0? Nowhere. Nowhere. Because the graph does not go below the x-axis. All right? So if it says give an explanation, you've got to be able to give something that you know, states your understanding that you know why it's not less than 0. Okay? Last question, why does f of x bounce off of the x-axis? Well, this goes back to Algebra 2 a little bit here, but when we graphed in Algebra 2, this guy has two factors. Okay, so f of x has two factors of x minus 4. Okay, so in the original function it says x minus 4 squared. Okay, so these two factors produce two solutions, okay, which implies two solutions at x equals 4. Okay? Now, these solutions are called zeros. Okay? So, solutions with even degrees. And I might not be saying this perfectly. Solutions with even degrees cause the graph to bounce off the x-axis. All right, so we'll talk more about that later on, but that was one of those things that we talked about in Algebra 2 quite a bit there. All right, we'll talk about that again in this class. All right, so number 2 says use the graph of g of x, and this one's got quite a bit more going on, x cubed minus 2x squared minus 4x plus 8, given to solve the inequalities. Now, so these are my questions over here. Where is g of x greater than 0? So the first thing I want to do is I just want to look at, where is it equal to 0? So I've got a point where it's equal to 0 here at -2 and another one here at +2. And so where is it greater than 0? It's greater than 0 in between -2 and 2. All right, so I would say -2, comma +2. You'll notice I'm using parentheses because it doesn't say equal to. Not sure what happened there. Let's see if we can get this back here. All right, here we go. And it also, after 2, you'll notice at 2 it's equal to 0. We're saying greater than 0. So after 2, it's also greater than 0, again going up to the right side. So we would have to include 2, comma, infinity. All right? When it says where is g of x less than 0, it's basically asking where is g of x below the x-axis. That's what it means. So if you look at the graph over here, it's below the x-axis before -2. Okay, when I say before -2, I'm saying everything to the left of -2 is below the x-axis. So that means that from -infinity all the way up to -2, I am below the x-axis. Okay? Where is it equal to 0? We've already talked about that. We're equal to 0 at x equals -2 and +2. Let me see. How many factors are there for g of x? All right. Now, how do I know how many factors there are? Well, I've got an x-intercept at -2, and I've got a bounce at +2, so there's got to be at least 2 factors at 2 and 1 factor for -2. And this is a third degree function, which means it can only have 3 factors. Okay, so there are 3 factors because of the way this equation is set up and the way it's graphed right here. We could only have 3 factors. And then it says use the graph to list the factors. So if I have a solution, all right, so let's talk about that. If I have a solution at x equals -2, that implies that I have a factor of x plus 2. And if I have a solution at x equals +2, that implies that I have a factor of x minus 2. And there are actually 2 factors. 2 factors. My screen keeps going out on me here, so again, I hope it's not happening in the video, but I'm not sure what's going on. All right, so here we go. Next one, I would encourage you to turn off the video and try these on your own, okay? Try them on your own. All right, so based on this graph here, you'll notice there's no arrow on the left-hand side here. So this graph stops right here. There is an arrow, however, on the right side. So where is r of x greater than 0? Well, it looks to me like it's hitting the number 3 on the x-axis, and then it's above the x-axis. So it's going to be greater than 0 from 3 to infinity. Okay? From the interval 3 to infinity. Now again, when we talk about intervals, we're talking about some x value on the left, so we'll call that x1, to some x value on the right. When they say given interval, okay, we're talking about x values, some x1 to some x2. Where is r of x less than 0? Well, it's less than 0 starting at -1, and it stops being less than 0 at +3. So, boy, not sure what's happening here today. Sorry about that, guys. Boy, my computer is not doing well here at all. All right, so we've got -1 to 3 where it's less than 0. Obviously, then we're equal to 0 at x equals 3. Mark the minimum, maximum, or minimum values of r on the graph. Okay? So this point right here, we would call this an absolute minimum. Okay? It is the smallest y value on the graph. Absolute minimum at y equals -2. There is no maximum and there is no absolute maximum on this graph because it just keeps moving up forever and ever and ever. Okay? All right. Now, while we're talking about intervals here, we're going to talk about where a graph is increasing or decreasing. Okay? So given an interval, and we'll just use the letter I, that is a subset of the domain. Don't worry about what that means, and we'll get there in a second. With x1 and x2 in the interval. So again, when we talk about an interval, we're talking about some interval, and it could be brackets or parentheses depending on what we're talking about. But we're talking about some x1 all the way to some x2 in the interval, where x2 is greater than x1. So your x1 is the smaller part of the interval, your x2 is the bigger part of the interval. You wouldn't ever write an interval like this, 2, -3. You wouldn't do that. Okay, we can do coordinates like that, but we don't do intervals with the bigger number on the left. So what does this mean? It means that any two x's that are part of the domain where one x is larger than the other x. That's all that means. That's what an interval is. Okay? When we talk about increasing, all right, we say that a function is increasing on the interval if f of the second number is greater than f of the first number for all x's in the interval. In other words, let's just say for a minute that we were using the interval 1, 7. All right? So we would say that this is increasing if f of 7 was greater than f of 1. In other words, I would need a graph that looks something like this. Let's say that f of 1 turned out to be here and f of 7 was over here. So you can obviously see that there's an increase from 1 to 7 there. That's what it means to be increasing. Putting it in words, larger x values, okay? So as I go further to the right on the interval, larger x values produce larger y values. That's what it means to increase. A function is increasing if it rises from left to right. All right? Now, if increasing makes sense, then decreasing should certainly make sense as well, because it's pretty much the opposite of increasing. So function is decreasing on an interval if the second x value if f of the second x value is less than f of the first x value. Okay? So again, using my numbers 1 and 7 from the previous interval above, going from 1 to 7, is f of 7 now less than f of 1. Okay? So when we think about this, what are we talking about? Okay? As x values get larger, so larger x values produce smaller y values. Okay, so I can know just by looking at the values of, plugging in for x or plugging in plugging in an x value and seeing if the next x value is smaller or bigger, whether a function is increasing or decreasing. A function is decreasing. Hang on a second here, guys. Now I really got a problem going here. So a function is decreasing if it drops from left to right. Okay? And constant. A function is constant on an interval if f of x2 equals f of x1 for all x1 and x2. So again, using my example from above, let's say we were on the interval 1 to 7. Okay? And actually the way I'm doing this, these probably should be square brackets, but let's say we're on the interval from 1 to 7, and we were to plot these 2 points. Okay? So here's 1, and here's 7. And so in this case, constant means that there's no change in height. That's what constant means. So larger x values produce identical y values. Okay? That's what it means to be constant. Let's take a look at some examples here. Number 4. Use the graph of f of x equals negative x squared plus 4x plus 5 to give the intervals where f is increasing or decreasing. Label any maximums or minimums. Okay, so, well, here we go. First thing I'm going to do is I'm going to label this as a max. This is actually an absolute max because it is the highest point. And it is an absolute max at y equals 9. When we talk about maxes and mins, we're talking about y values. All right? So there's my max. Where is this function increasing? Notice my notation here. F of x, the little arrow means increasing for x in the interval. Okay? So I basically want to know as I move from some point on the left to the right, where's my graph going up? All right? That's pretty easy to see. My graph is going up all the way in this section right here. Okay? So as I come across from left to right, this graph is increasing. Now, because it never stops increasing, we say that x is in the interval from negative infinity. So it's increasing from negative, where x is negative infinity, all the way up to where x is equal to positive 2. Notice again, I'm looking at x values here. This is x1, this is x2. So from some smaller x1 to some larger x2, my graph is increasing. Where is it decreasing? Well, it's decreasing from 2 on. So from 2 to positive infinity, my graph is decreasing. Again, this is some value of x1. This is some value of x2. Where are the zeros? The zeros are at x equals negative 1 and 5. All right? So I would encourage you again, turn off the video, try these on your own, and then come back and see what you get. All right, increasing. All right, increasing. Actually, you know what? It says label any maxes or mins again, doesn't it? So here we go. Look at this. Max. This is actually an absolute max. Absolute max. There is no min on this because we got arrows on both sides. We wouldn't count this value over here as a max because it does come up. It doesn't really go anywhere at this point. I'm not, because it's constant across here, we wouldn't label it as a relative max. Okay? So, where are we increasing then? We are increasing always on the left up until this point right here. I am increasing. So when x is in the interval from negative infinity all the way to negative 2, we are increasing. Then we actually go constant for a while, and then we increase again from 1 to 3. So we would include the intervals 1 to 3. Notice I'm using parentheses here because at the points where we stop increasing, it's actually not increasing or decreasing at those points. We'll talk more about that later. Where are we decreasing? Where are we going down? Well, we're going down from 3, where x is equal to 3, and then we just continue down forever. So from 3 to positive infinity. Remember, this is an x value, some x1, to some x2. We're not talking about x and y here, only x's. And then where are we constant? We've kind of talked about that already. We're constant from -2 to positive 1. Okay? All right. Let's see what we got on the last page here. All right. It says, use the function f of x equals x cubed minus 3x plus 2 to determine whether the function is increasing, decreasing, or constant on the given intervals. All right? Now, constant is kind of tough, but if we're just looking at the two values, -2 to -1, we don't care what's happening at -0.5. We just want to know if the function is going up or down from -2 to -1. Now, you could graph this and you could just look at it, or you can just find the values. So I'm going to start off. Remember, this is an x1 and this is an x2. These are not y values. All right? So I'm going to actually plug these both into my function here. So what is f of -2? All right, so here we go. F of -2 is equal to, what do we got to do here? We got to do -2 cubed, -2 cubed minus 3 times -2 and plus 2. So I know that f of -2 is going to equal, this is going to be 8 plus 6 plus 2, or excuse me, -8 plus 6 plus 2, so that's actually going to be 0. All right? So f of -2 is equal to 0. Well, let's find out what f of -1 is. F of -1 is going to be -1 cubed minus 3 times -1 plus 2. And so f of -1, if we do the math here, we get -1 plus 3 is 2, and 2 plus 2 is 4. So here's what we're saying. You can see that the first value, f of -2, is 0, and the second value, f of -1, is 4. Now, just to kind of let you see what's going on here, here's my graph. All right? So f of -2 would be 0, and f of -1 would be 4, and you can see, easily see that it's increasing. So how do we say that? We say that because f of -1 is greater than f of -2, so f of x is increasing on the interval -2 to -1. Okay? Let's try another one. All right, -1 to 1. Are we increasing from -1 to 1 or decreasing? Okay, now, here's the nice thing. We've already done f of -1. We did it on the left side over here. So we know that f of -1 is equal to 4. That one's done. All we got to do is figure out what's f of 1. All right, so f of 1 is going to be 1 cubed minus 3 times 1 plus 2. So f of 1 is going to equal, let's see here, we got 1 minus 3 is -2 plus 2. Is this thing 0 again? We're back at 0? I guess we are. Okay, so if f of -1 is 4, okay, so again, just looking at it graphically, you can even plot these if it helps. F of -1 is 4 up here, and f of +1 is 0 here, so I'm obviously decreasing. All right? But here's how I'm going to say it. This is my x1, this is my x2. The question is f of x1 smaller or bigger than f of x2. All right? So I know that f of 1, okay, is less than f of negative 1. So f of x is decreasing on the interval negative 1 to 1. Okay? So I would encourage you to turn off the video, try the last one on your own, 2 to 3, see what you come up with here. All right, so f of 2 is going to equal 2 cubed minus 3 times 2 plus 2. So doing a little bit of math here, this is going to be 8 take away 6 is 2, and 2 plus 2 is 4. Wow, we get a lot of zeros and 4s in here, don't we? All right, and then we need to do f of 3. So f of 3 is going to equal 3 cubed. That's going to be 27 minus 3 times, minus 3 times 3. So that's 27 minus 6 is 21, and 21 plus 2 is 23. So f of 3 equals 23. So if you just do the first one first, x1, and then x2, all you got to do is look at the y values. Did they go up or did they go down? They obviously went up. So f of 3 is greater than f of 2. So f of x is increasing on the interval 2 to 3. Pretty easy to see, I hope, huh? All right? All right. Looking at some more characteristics of the graphs here. All right? Let's go back and find the top of that. All right. It says, analyze the graph of a function f shown to the right by giving each of the following. So number one, we're told it's a function, so it passes that vertical line test. Okay? So this is just kind of going back to what all the stuff we've already talked about. So I would encourage you, again, turn off the video, try and answer all these questions on your own, or as many as you can. All right? The domain of this graph. As I look at this graph, it's got arrows on the left, arrows on the right. That means the domain is all real numbers. Okay, so this is x in the set of reals. Okay, you could also write the interval negative infinity to infinity, but I like x in the set of reals because my infinities don't turn out too nice. The range on this guy, okay, this graph only goes to this, the highest point is right here at 5,7. Okay, now you can obviously see that the scale's a little bit different. It's going by 2's here, but the highest y value on this graph is 7. The lowest y value goes down to negative infinity. So my range, a couple of different ways you could write it. Most people like intervals, so you would say negative infinity, comma 7. You'd need a bracket with the 7 because it touches. Or you could simply say y is less than or equal to 7. That would also be okay. All right? I need some intervals where f is increasing or decreasing. Now, I got a bunch of those, and they're all pretty much marked out for me here. I've got a maximum, a relative max here. I've got a relative min here at 1, 1, and I have an absolute maximum at 5, 7. All right? So let's see here. We need increasing. So let's do increasing first. Increasing. So I'm increasing from the left side, from negative infinity all the way over to negative 3. So negative infinity to negative 3, I'm increasing. Along with, I start increasing again at positive 1, and I increase all the way until x is equal to 5. So positive 1 to positive 5. What about decreasing? All right, so decrease. I'm decreasing in this little interval from negative 3 to 1. So I'm going down in between those two x values. negative 3 to positive 1. And I'm also decreasing after x is equal to 5. I'm decreasing for the rest of the graph. So from 5 all the way to where x is at infinity, I'm decreasing. All right. Maxes and mins. Now we're talking about local maxes and mins and absolute maxes and mins. So when we talk about maxes, all right, so we're going to do max first. Max. And actually I'm going to do this. I'm going to say absolute max, absolute max. So we know that the top of this graph is right here at the 0.57. We don't care about this, the 5. A max is a y value. So my absolute max is y equals 7. But we also have what's called a relative max. Relative max. Now, here's the thing. A relative max is a maximum, but it's not the absolute maximum. So at negative 3, 5, I have a relative max, so I would need y equals 5. I also have a relative min. All right? Relative. Why do I not have an absolute min? Because this graph continues to go down forever on both sides, so there is no absolute min. My relative min is at the point 1, 1. So when y is equal to 1, I have a relative min. Letter D, intervals where we are greater than 0, less than 0, and equal to 0. Okay, well I'm going to do equal to 0 first because those are the easy ones. All right, f of x equal to 0 at, what do we got here? That's negative 2, 4, 6, and then positive 8. So x equals negative 6 and 8. We're basically saying, where do I hit the x-axis? F of x greater than 0. All right? So I'm greater than 0 all the way up. Anytime I'm above the x-axis, I'm greater than 0. So here's the thing. The nice thing is knowing exactly where these intercepts are at negative 6 and 8, because everything in between there is above. So my interval now becomes negative 6 to positive 8. I am greater than 0. You'll notice I'm not using brackets here because we don't include the negative 6 and the 8. Whereas f of x less than 0, well, it's less than 0 to the left of negative 6 and to the right of 8. So I need two intervals. I need the interval from negative infinity to negative 6, and I need the interval from 8 to infinity. All right. Let's see. You know what? We're going to skip letter E because we didn't do odds and evens here, so don't worry about that. And letter F. What are the zeros of F? Oh, we already got those. Equal to 0. X equals negative 6 and 8. Look at that. What a piece of cake, huh? Hopefully it was easy for you too. See you on the next one.